All right, folks, we're going to wrap up what we're talking about with properties of logarithms. So we're going to continue our discussion about logarithms and logarithmic equations and expressions, and we're going to kind of wrap up with the last lesson of the year. Again, this is just an overview. This is nothing of great detail, so this isn't really the video you're looking for if you want a lot of details about logarithms. We're going to kind of fly through some things here. So first thing, we're going to figure out how to evaluate logarithms. So I'm going to not give you the answer like I did in the last video. In the last video, we were looking at rewriting logarithms as exponentials. Well, here, we're still going to kind of use that idea, and that idea is going to help me to evaluate these different logarithms. So let's take a look at number 1 here. Log base 4 of 64, and I want you to evaluate this instead. So in this problem, what that means is I need to figure out 4. Again, rewriting it as an exponential, right? 4 to, okay, if I don't know what that is. So 4 to what power is going to give me 64? And it's kind of all about going back to that exponential form and thinking about 4 to what power gives me 64. Now, if I were you, I would have maybe like that list of perfect squares, perfect cubes, perfect fourths that we made back when we were talking about simplifying radicals. That may be really helpful here because I bet you can find 4 and to what power gives you 64 pretty easy in there. Because you should know that 4 to the third power gives you 64. And if 4 to the third power gives you 64, what that means is the log base 4 of 64 is in fact equal to 3. This exponent becomes the answer to the logarithmic expression. Let's look at number 2. This is log base 5 of what? Log base 5 of 0.2. Well, again, this is 5 to what power will give me 0.2. Now, that's a little weird because I don't exactly know what 0.2 is, but 0.2 is 1/5. So the question is, how do I go from 5 to 1/5? Well, we could guess and check in our calculator, or we could think about this 1/5 as being 5 raised to the negative first power, because if I do that, that puts me 1 over 5 to the first, which is in fact 1/5. So log base 5 of 0.2 equals -1. That's my answer. Let's look at number 3. Log base 36 of 6. Well, that's weird. 36 to what power gives me 6? Well, I'm not used to making things smaller. But here's what I do know. I know that the square root of 36 is equal to 6. So what is a different way to write this radical as an exponent? Well, we learned that a couple sections ago. We know that if we raise 36 to the 1/2 power, that's the same as taking the square root. So 36 to the 1/2 power is 6. So my answer, 1/2. All right, what about over here? What about number 4? Log base 1/5 of 125. Ooh, 1/5 to what power is going to give me 125? Well, let's see here. 1/5 is not, how do I go from a fraction to a whole number? I'm going to have to make that big. Well, here's the deal, folks. Whenever you're going from a fraction to a number that's bigger, I know, again, that some negative is going to have to be involved. I know I'm going to have to raise it to at least the negative first power, but 1/5 to the negative first power will just give me 5. So that's not going to be big enough. We need to keep going. Here's the other thing I'm thinking about. The other thing that I'm thinking about is 5 to the third power. I know 5 to the third power is 125. So how do I go from 1/5 to 125? I got to take both of these things into account. So the actual answer is 1/5 to the negative third power. That will, in fact, flip my radical or flip my fraction here and make that 5 to the third power, which I know is 125. So the answer, what is the log base 1/5 of 125? -3 is the result. These get tricky, but with some practice and some understanding of how these numbers grow, you will get better at these rather quickly. And we'll practice those here in a moment. But first, let's talk about a common log and a natural log. Common logs are logs with a base of 10, and we just usually write the word log. We don't bother with the 10. It's kind of like writing the square root, not putting the 2 up there in the index number. And a natural log is log with a base of e, but we have a special symbol for that. We use the lowercase ln for that, like you see over there in number 2. So the easiest way to evaluate these is to use a calculator. Find that log button on your calculator, press the log, enter that into your calculator, log base 8. You should get a crazy decimal of 0.9030, and it keeps going after that. When you type in the natural log of 0.3, again, find that button in your calculator, enter it in, you get negative 1.203, and it keeps going from there. Folks, you just got to find the button in your calculator and use that button in your calculator. Again, I'm not with you right now, of course, but I can show you in class where that logarithm button is if you need to know. So at this point, why don't you pause the video and take a look at these 4 problems. I know with number 3 and 4, you're going to have to use a calculator for those 2, but with 1 and 2, you're going to be able to use those without a calculator, see if you can't figure out what those are equal to. Go ahead, pause the video now, try these out. Okay, now that you've had an opportunity to try the problems, let's go here. So number 1, I'm going to rewrite this as 2 to what power will equal 32. 2 to what power will give me 32? And of course, I know 2 to the 5th power equals 32. So my result is, of course, 5. What about number 2? 27 to what power will give me 3? Oh, well, I know the 3rd root of 27 is 3. So therefore, I can rewrite this as 27 to the 1/3 power will give me 3. So my result is 1/3. Log of 12, again, that's just typing in your calculator. You should get 1.0791, and it keeps going. And of course, the natural log of 0.75 is negative 0.2876, and it keeps going from there. So what if the numbers aren't nice numbers? What if I end up with something that's just, I don't know. It's like something that I can't do. We'll see examples of that on the next screen. We do have something called the change of base formula. And change of base formula is really nice. It makes the math a lot easier. But it does involve using a calculator every single time to do that. So what we can do is we can rewrite a log base c of a. We can rewrite that as the quotient of 2 different logarithms. Typically, we use a common log or the natural log. And if you'll notice where these numbers go, you'll see that the big number is what we have the number on the top, and the base number of the logarithm is a logarithm on the bottom. And that's no different for what you'll see over on the other problem. Again, log base c of a, that a is the log on the top, and the c is the log on the bottom. Let me show you an example of them here. What if I wanted to evaluate log base 3 of 8? If you think about it, 3 to what power will give me 8? Ooh, that's really gross. I know 3 squared is equal to 9. That's too big. And I know 3 to the 1st is equal to 3. So my answer has to be somewhere between 2 and 1. But what could it be? How could I figure that out? Well, the change of base formula is going to let me figure that out by using the calculator. So what I'll do is I'll rewrite that as the quotient of the log of the log base 3 of 8. So log, that big number is 8, so the log of 8 goes on the top. And the base number, it's log base 3, so log base 3. Log of 3 will go on the denominator. And now when I type this in my calculator, and I do log with a base of 8 divided by a log of base of 3, I get 1.8927, and it keeps going. That makes sense. 8 is almost 9, so I knew my result was going to be really close to 2, the exponent here. Let's try it again. Log base 6 of 24. Well, 6 to what power gives me 24? I know 6 to the 1st is 6, and 6 to the 2nd is 36. So I know my answer is somewhere in between 1 and 2, right? In between the exponents, between 1 and 2. My calculator is going to help me out. So I'll rewrite that as the log of 24 divided by the log of 6. And if I type that in my calculator and I come up with the answer, I'm going to come up with the answer of 1.7737, and it keeps going from there. Very close to what I thought the answer was going to be. Okay, now let's talk about some properties that logarithms have, some things that can make the problems easier. Okay. We have the product property, the quotient property, and the power property. These very much resemble some of the rules of exponents that you have. Because logarithms and exponentials are so closely related, the properties are going to mirror those a little bit. So, for example, if I have the log of two things multiplied together, I can split that up and make it the log of the first number plus the log of that second thing. If I had a quotient, the division turns into subtraction. And if I have the log of something raised to a power, I can take that power and write it in front of the logarithm. So like for example, I might have the log of 2x. If I have the log of 2x, that's a multiplication, 2 times x. That allows me to rewrite it as the log of 2 plus the log of x. Quotient, what about that quotient rule? Yeah, I could have something like the log of x divided by 5. Well, that would allow me to rewrite it as the log of x minus the log of 5. Down here, I could have the log of x squared. That's exactly the same as 2 times the log of x. Now, the importance of these properties happens when we solve logarithmic equations. Good news, we're not going to get to that this year. Or bad news, I don't know how you want to view that, but we won't get to that this year. So the application of this, you're just not going to see until you work with logarithms again. So it actually allows me to do some simplification that I couldn't do before. Before we had calculators, these problems would have been very difficult to do. We would have had to look up different values for logarithms on a table of logs, and we'd find that like the log base 2 of 3 was 1.584 and log base 2 of 7 is 2.807. And then we'd have to figure out different ways to write these logarithms using just those two properties, because not everything would come up on this table of common logarithmic expressions. So what you would have to do is you'd have to take something like here in A, log base 2 of 3/7, and you'd have to rewrite that as the log base 2 of 3 minus the log base 2 of 7, right? That's using those properties of expanding logarithms. And then you'd be able to go to your decimals and write out the decimal equivalent of those two numbers and come up with your final answer. Now, this is before the use of a calculator, right? So we could very easily plug these in using the change of base formula, but I think it's kind of important that we can recognize how different numbers are formed using just the 3 and the 7, meaning this 3 and this 7. Like, for example, I know that log 21 is really 3 times 7. So this would allow me to break up this and rewrite it as a log base 2 of 3 plus the log base 2 of 7, and I'm able to get the answers, again, by getting to these decimal equivalents and then simply adding those two numbers together, coming up with a final answer. Same thing here with this 49, recognizing that 49 is in fact 7 squared, and using the properties of logarithms to simply rewrite this as 2 times some other decimal. It's kind of neat that we can do these things. But again, with the use of a calculator, it becomes fairly impractical for us to do this. But regardless, why don't you try to do it with these two problems? So just take a minute, use your properties of expanding logarithms to rewrite these in a different decimal form. So pause the video and try them out. Okay, here are your answers. So let's first do log base 6 of 5/8. Well, again, remember that this is the same as log base 6 of 5 minus the log base 6 of 8. Those decimal equivalents will get us the answer of negative 0.263. Again, over here, recognizing that this is really 8 to the second power will allow me to use my expanding logarithms to rewrite this into this form. And then again, to finalize the answer as 2.322. Most of the time we see it with algebraic expressions, but my properties don't change. The important thing is to kind of expand it and do it step by step. So I see the quotient rule. By the way, that's a 7 right there. That's the natural log of 5x to the 7th power over y. So I'm going to deal with the quotient or the product rule first. I always do with that first. So this will turn into the natural log of 5x to the 7th power minus the natural log of y. And now I can just work with this first part. And I see a product rule. So I can rewrite this as the natural log of 5 plus the natural log of x to the 7th power. Then I still got that natural log of y that comes along for the ride. Now here, right, I see x to the 7th power. So I know that I can expand that further by writing it as 7 natural log of x. And again, everything else just kind of goes along for the ride. When you don't see any more multiplication, division, or exponents, you know the problem is expanded as much as it can be. Of course, we can also go backwards. So we can take this expression log of 9 plus 3 log of 2 minus the log of 3 and come up with a simpler form for this problem. And it's doing everything backwards. So the first thing I'm going to do is I'm going to look for any of those exponent rules. So that's just here in this part. So let's see here. I got the log of 9, which I'm not going to do anything with yet. But I can rewrite this as the log of 2 to the third power. And then that minus log of 3 is going to stay put. Okay, so log of 9, nothing happens with. But that 2 to the third power is in fact 8. So I can do that math. Okay, now what? Well, now I'm going to deal with this addition, which turns into a product. So that'll turn into the log of 9 times 8. And of course, this minus log of 3 will just kind of be along, which turns into the log of, let's see here, 9 times 8 is 72, minus the log of 3. And now I remember about the subtraction. The subtraction means to change it into division. So that's 72 over 3, which if I do the math, that's the log of 72 divided by 3 is 24. So this whole expression right here is exactly the same as the log of 24. Don't believe me? Type it into your calculator. You will get that as your result. So at this point in time, why don't you pause the video and you can try to expand and condense both of these 4 example problems. So expand the top 2, condense the bottom 2, and then we'll go over those answers momentarily. So go ahead, pause the video, try them out, see if you can do them. There's really not much to these problems, not a lot of work. So I see multiplication, so I'll change that into a sum of 2 separate logarithms. And then I see an exponent, so I can rewrite that as 4 in front of that log, and that is my final answer for A. For B, I see quotient, so I can rewrite that the natural log of 5 minus the natural log of 12x. Hey, that still has some multiplication, so I'll expand it out more and turn it into the natural log of 12 minus the natural log, plus the natural log of x. Please notice that I have that in a set of parentheses. That's really important because both of those things are on the denominator. I could also distribute the negative and come up with either of these as my final answer. What about condensing? Well, again, here for part C, I see subtraction. So that just simply turns into the log of x over 9. That's all there is to it, all done there. What about here? Well, this first part right here, I'll know that that will be 3 to the third power. Right, so I have the natural log of 4 plus natural log of 3 to the third power minus the natural log of 12. 3 to the third power is, of course, 27. Let's keep that in mind. I'll deal with these two first. That's a sum, so that turns into a product. So I really have 4 times 27. And 4 times 27 is 108. So I have the natural log of 108 minus the natural log of 12. The subtraction turns it into a division. So I really have 108 divided by 12, which is 9. My final answer is the natural log of 9. All right, folks, this has been a very quick overview of logarithms and properties of logarithms, but it should be enough to get you started on the practice problems. So good luck, folks.